Okay, so we're in 10-1. This is chapter 10 of our old textbook, Adding and Subtracting Polynomials. Learning goals, describing polynomials, and then obviously being able to add and subtract them. Some of this is going to be a review to you. Okay, so the first bit of information you need to have down is how to classify polynomials. Okay, this is on page 262, so if you want to use a textbook, you definitely can. But to classify polynomials, you can describe or classify polynomials that are in standard form by its degree and by the number of terms. So if you look at a polynomial, say like this polynomial here, doesn't seem like poly meaning many, and we got many terms here. Well, there's only one term here. Okay, if it has one term, it's called a monomial. So when you're really looking at this classification, you're thinking of terms that are separated by addition and subtraction signs. So if that's something that's new to you, like you didn't know a term was separated by an addition or subtraction sign, that's probably something to put down there. Okay, so terms, this one has one. It's called a monomial. Mono meaning one. Okay. This has one and two terms because you have the addition sign in between. That's two terms. It's called a binomial. Bi meaning two, like bicycle. Okay. 3x squared, that's a single term. Okay. The multiplication signs in between, that does not separate terms. Okay, so that's still a single term. That's one. Once again, it's a monomial. And then if it has three terms, so 1, 2, and 3, that's called a trinomial, like a tricycle, or tri meaning three. Okay. If it has more than three terms, so if it has 4 plus terms, we call it just a polynomial. That's how we will classify it in here from there. Anything more than or 4 more terms, we're just going to call it as a polynomial. Okay? All right. Degree means once you put it in standard form is when you have your variable, your highest degree variable. So if, say you had an x squared, an x cubed, okay? If you had all of those things and then maybe a constant, so let's just put some plus signs in between those. Okay? Standard form means you're putting it in order from highest degree to lowest degree. So this would be a positive x cubed. And so that would be the first thing I'd write. This is a positive x squared. This is I'm going to put a negative there so we see that's a negative x and a positive 3. The constants always go at the end. So that is standard form. It's when you put your polynomial in order from highest degree to lowest degree. You're counting down. Okay. So when I look at something that's in standard form, if I look at the degree, if it's just a constant, that's a 0 degree. That would mean you'd have x to the 0, which remember, anything to the 0 is what? It's 1. So like if I add 3x to the 0, that'd be 3 times 1, or just 3. Okay, a 0 degree is called a constant. Okay, a first degree, x to the first power, if we don't see a power, remember it's 1, is called linear. Now you've dealt with a lot of linear this year. Alright, so we're looking at just degree in this spot here. If it's second degree, we call it a quadratic, and that's actually what we're going to be studying a lot of in the next month or up to spring break. Okay, and then if the highest degree from there is a third degree, it's called a cubic. Okay, those are special names. Any degree over 3, so 4 or higher, we're just going to call whatever, if it's whatever that is, degree. Okay? So in this case, we would call it a 4th degree, or a 4th. If it was 5th power, we call it a 5th degree. If it was 6th power, we call it 6th degree. Okay, so we just keep changing that term. Okay, we're not going to use any special names from there. Okay. Notice this one you see multiple degrees in. Tell your neighbor how you know which one of those to use to name that. What did we use up here?
Cubic.
We used cubic, which is what degree? What power is it? Jade? Third degree. So how do we know which one to use? Like, why didn't we use the 2? Why didn't we use the second power or the constant? Any thoughts?
Cubic came first.
Yeah, cubic's first. It's the highest degree. You always use the highest degree. Okay? So make a note to yourself. Sound like no one knew that. Make a note to yourself. You have to use the highest degree. All right. Any questions there? Right. I want you to tell your neighbor 3 things that you learned from that before we move on. Give me one thing. Shake, what's one thing?
1 equals monomial.
Okay, in terms of terms, 1 is monomial. Another thing. Trinity?
You always use the highest power.
Okay, you always use the highest power to determine the degree. Good. One more thing. Oh, come on, one more thing. I know it's like Tuesday, but it's actually Monday. One more thing. That's all you guys learned from that? You spent 6 minutes doing that? Dude. Billy?
Any term that has 4 or more, like these numbers is called a polynomial.
Okay, anything with 4 or more terms called a polynomial. Okay, well, since we've learned all that, and it seems like we knew most of it there you got it. Without talking to your neighbor, match them up. No cheating right now, on your own. Okay, who's matched up with their neighbor? Oh, a couple of you. All right, well, let's see. Let's just go through without even looking at this side. By degree. What is this called? Yeah, Annalise? Not linear. No. Second degree. Chelsea? Quadratic. Yeah, we're going with the highest here, so this one's quadratic. Okay, by degree, what's this one called? So we're focusing in on the highest power here. Highest power in this one is a? Everyone? This is a 1. Okay, so if that's a 1, what is this?
Mono.
It's just linear. Okay, so you're thinking of terms there. Mono. Okay, what's the highest power in this one? Highest degree? 3. Okay. It's a? Cubic. All right. Highest degree in this one? 1. It's called? Based on what we know, it's called linear. Okay. What's highest degree in this one? 0, right? There isn't one. So we call it 0. It's a? Constant. All right. Okay. By number of terms. All right. Ryan, how many terms?
5.
No.
Oh.
Look at addition and subtractions. How many terms?
2.
Nope. There's a term.
Oh, 3.
There's a term. 3 terms. What do we call that? Trinomial. All right. Toki, by number of terms, how many?
2.
2? What do we call that?
Binomial.
Binomial. Cole, by number of terms, how many? 3? What do we call it? Trinomial. Ayla, by number of terms, how many? 2. What do we call that? Binomial. Marie, number of terms, how many? 1. What do we call that? Take a look at your notes. One term. Monomial. All right, so matching up. Constant monomial, that looks like number 5 is letter A. Number 4 is letter, we'll come back to that one. Number 1, what's that one? C, okay. Number 2 is? D. Number 3 is? E. What's that leave number 4? Not a polynomial. That's odd. Tell your neighbor why that one's not a polynomial. Anyone think they know why it's not a polynomial? We haven't talked about it this year, so it might just be a complete guess. What looks different? Caden?
Is it because the 3 is over the x?
Yeah, it's because your x is in the denominator position here. So technically it's a binomial, but it's not linear. This is actually called a rational expression. Okay? So that one doesn't work. It's not a polynomial. It is a binomial. Okay? I guess there are 2 terms if you want to think of it that way, but it's when x is not when x is not being multiplied by a constant, when it's being divided like that, you end up getting a rational function. So we don't even classify it. Okay? Letter B there. Any questions? All right. So while I'm passing out some of your stuff here, I want you to find the sum of both of those. Okay? Write your answer in standard form. Actually, before we do that, do this. Let's go to this. Write each polynomial in standard form, and then classify it by degree and number of terms. Go for it.
Keep down in your
Okay. So, all right. So, Chelsea, you get the first one. Number 1 there, you can bring whoever you want with you. And second one goes to TT. You bring whoever you want with you. All right. Go for it. So standard form and then classify degrees and terms there. One is question number Ryan. Ryan, that's you, man. It's all you.
Okay.
Bring whoever. Well, you bring whoever you want with you.
Here, let's go. Alex.
Just double check, you know.
I haven't done it. Okay.
All right, be checking your work as they're putting them up. See if you guys match up. If you match up and you think you got it, you could try questions 1 through 16 or 1 through 18 on the sheet I gave you today.
You have done it.
Try to work through those while they're doing.
What? What happened?
He
those other
hasn't
ones
done
up
it
there.
yet.
Were you able to get on the server?
What?
Were you able to find the page?
It's not. It's okay.
running over 100 FPS.
It's gonna be long.
Just run 64 at John.
Got it, huh?
Yeah.
All right, let's check them out. All right, let's see how we did. Number 1, 2x squared plus x. Well done. Got standard form. Nice work, Chelsea. And it's linear. Binomial. It's a binomial. It's not linear, unfortunately. Well, I don't know if it's unfortunate or not, but it's, what is it? Yeah. It's quadratic, yeah. How's it quadratic? Good question. Brennan, how's it quadratic? Yeah, the highest degree once in standard form is 2. So once you get it in standard form, your first term, your highest degree is 2, so it's quadratic. Very good. Questions? Ask your neighbor if they have a question about this, not about life. Any questions you couldn't answer about woodchucks or anything like that? Patrick? Oh, you're just joking. All right. Mackenzie, got it? Sort of. Okay. Well, let's see on this one. Quadratic because it's a set. The highest degree is 2. It's a trinomial, and standard form looks good. All right, TT, well done. Any questions on those two? Anything that I can clear up? I'll check. Yeah.
I'm just confused on how you figure out if it's like constant or linear or quadratic.
So once you have it in standard form, you know how to get it to standard form?
Yeah.
So once you have it in standard form, to figure out if it's linear, constant, or quadratic, you just look at your first term. In that first term, look at the power. If the power is 2, it's quadratic. If when you get it in standard form, say like on this one, the power, I think there's supposed to be an x there. Okay, but the power is 3, so it's cubic. If the power is 1, it'd be linear. So we got it here. Hey, I like the way Ryan made sure he pulled the negative sign with it. Well done, Ryan. Okay? Make sense, Mackenzie?
Yeah.
All right, thanks. Questions? All right, we're going to take the next 4 or 5 minutes, work through 1 through 18, and then we're going to start on example 2 after that. So you have your assignment in front of you. Start working through the 1 through 18. Cole? There was a reason I didn't give you guys one. Probably because I forgot. But makes sense compared to what you guys are doing? What are you thinking?
Yeah.
Okay. All right. Hey, let's move into example 2. I know you may not be done with example 1, and that's okay. But I gave you some work time, and if you don't finish, you can work on it a little later. Look at it. Let's take a look at example 2, number 19. Write the sum. Write your answer in standard form. So go ahead and tell your neighbor how you're going to add number 19 together, what you think you should do. Okay? You get about 30 seconds. All right, Jake, what do you think?
Oh.
I got it.
I think that you have to add 3x to the 3x to the second power and 5x to the second power to get 8x to the second power plus 4, and you have to add negative 4 and 8.
That's good. You got it right. 8x squared, so he's taking the 3 little x squared, so this means you're counting x squared. You have 3 of them. So repeated addition we call multiplication. 1, 2, 3x squareds. Here you have 5x squareds. We're running out of room here. Okay, so you have a grand total of 3x squareds and 5x squareds, or 8x squareds. All right? That's kind of what's happening there. All right, and then you have negative 4 and positive 8, which is positive 4. Okay, notice the addition sign in between. That's what's causing that. All right, don't multiply them. Don't subtract them, just adding them. 3 plus 5 is 8. Negative 4 and 8 is positive 4. You add your like terms. So if I'm looking at number 21, right there, JC, what's a like term for 4y squared? What's another one like it? Good, yeah, you got 4y squared and we have 6y squared. We put those two together by adding, so that gives us a total of 10y squared. All right, I want everyone to finish that one up. Okay, now that you're done, finish. Go ahead and compare it with your neighbor. Make sure you guys match up. If you don't, try to figure out what's up. Where you're thinking different. Parkar, what do you got for the next term? Positive 3y. We've got a negative 3y and a positive 6y. So grand total of positive 3y's. Okay, negative 3 plus 6 is positive 3. And then we have the last term. Patrick, what do you got? Good. We have the 8 and the negative 9 to give us negative 1. Now, from that point, can we combine these two? How many say yes? Raise your hand. How many say no? Tell your neighbor why you cannot.
Because they are to the different degree.
All right, Toki, what do you think?
Because one of them has a power and the other one doesn't.
One has power, one doesn't. Okay? They don't have the same degree. Yeah, very good. 10y squared plus 3y minus 1. How many got it? Good. Now you'll notice I use different shapes up here, and when I use the shapes, I try to include the symbol in front. Some students like to do that. They like to put different shapes, the same shape around the like terms. It helps them out. That's up to you. Don't have to. Okay? All right. Okay, so let's go ahead and take about the next 5 minutes, work on example 2 there. Let me go ahead and get your attention up here. A couple questions. First one was this. Really good question. Like on number 26. Guys, when you get to this, notice when I look at my x cubes, I'm like, well, how many x cubes do I have over here? I don't have any. So that's like having 2x cubed plus no x cubed, so I just have 2x cubed. Okay? And then how many x's? Well, I've got negative 9x, but notice I have this x squared here. Okay, so the next degree after cubic is squared, and I have an x squared here, but I don't have any over here, so that just means I put them next to each other there. And then I've got my x's. I got positive 6 and negative 9, or negative 3 x's. And then negative 7 constants and negative 5 constants, so a grand total of negative 12 constants. Okay, so make sure you don't add those two powers or anything. Good question. All right, any other questions that came up? Okay, example 3, take a look at it. It's the last piece, and then I'll got 2 problems, and then I'll be done talking. So number 35, I'm going to go through it with you just real quick. Well, actually, tell your neighbor what's different about it first. Okay, it's very true. It is subtraction. Now, anytime, and this is something you need to learn in math, you should really somehow write it down or ingrain it in your memory somehow. Writing it down is the first step to that. If you have a negative sign outside of a set of parentheses, I always circle it to remind me, dude, I got a negative right there. And what that does, as you're going through it, it takes and it really is being distributed in. It's like having a negative 1 that you're distributing to each part. So you're multiplying each of these things by negative 1. That's like having a negative 1 there. Now really what I do, how I think of it is I just add the opposite. Your mind generally works better in addition, so what I do is I just go, well, I know that's subtraction, but really what I could do is just take and make it addition and flip all these signs. So this was positive, it's now negative. This was positive, it's now negative. And this was positive, it's now negative. Okay, and that kind of then eliminates the process of having to distribute that negative in. You've automatically done that. So if you just change that to addition and then flip all of those signs in there, if they were negative, they would become positive. So if they're positive, they become negative. If they were negative, they would become positive. Mackenzie?
Did you do it on both sides?
No, you only do it for the one that it's going right before. Okay, you don't do it over here. Okay, so from that point then, now you could add your x squareds. You have positive 5 and negative 3, or positive 2x squared. And you could add your x's. You have positive 4 and negative 1, so positive 3x. And you can add your constants. Positive 8, negative 3, or positive 5. Questions? I'd like you to try number 36, okay, the next problem there. Make sure you note it says write it in standard form at the end. So there's number 36. Give that one a go on your own. All right, go ahead and compare them with your neighbor if you haven't done so already.
What's good?
Okay, let's see. Make that a plus. Make that a negative. That becomes a negative. This one becomes a positive. So when I'm going through and looking at it, I have 8x squared and negative 3x squared. Now I can just add them, so that gives me 5x squared. I've got negative 4x and negative 6x, so I've got a grand total of negative 10x. And then I have my 1 and my 4 to get 5. Any questions there? How many got it? All right. So your assignment is to finish up this packet. Should be a good chunk of the way done, I hope. All right, that's the goal. All right, let me know if you need help.